Hi guys, today I will be starting with the next lecture, that is constant. So in the overview lecture that I discussed earlier, prior to this lecture, I already explained that I will be covering the topics, that is constant, variable and keywords, in different lectures for your convenient purpose. So that's the reason I'm taking this constant in a separate lecture. So later you can refer this lecture separately and just you can cover all the points which are there in this constant. It is very much convenient and will be very much interesting for you. So let's start, guys. So what is this constant? So constant is an entity whose value cannot be changed. So we have seen in our overview lecture that we have taken the example like whenever some operation is performed, say addition, and the result is say 10. So you to access it, this result, there is a variable that is called as I is equal to 10. If the result is 10, I is equal to 10. So next time you're performing the addition operation, input is different and you're getting result is 20. You can see different time the same variable is having 20. So at one time it is having 1 is 10 and at the other time it is having 20. So the variable is having different values at different times. So that is a variable, and constant is 10. 10 is constant, it cannot be changed, and 20. Later we got 20 after giving different input. So it is 20, it cannot be changed. So it is constant. So constant is the entity whose value cannot be changed. So let us see ahead. There are two types of constant. So guys, primary constant and secondary constant. So the primary constant, they are integer constant, real constant and character constant. And secondary constant, so primary constant, integer, real and character, I will discuss each and every constant ahead. And what is secondary constant? Structure, pointer, array, union, enumeration. So guys, I understand this is new for you. Now it will be new, but you will be getting used to each and everything in detail, as well as when we cover in our chapter wise, all these topics will be covered. So guys, structure, pointer, just for now you understand, structure, pointer, array, union, enumeration, these are derived from this primary constant. So we will cover here in this lecture integer, real, character, and secondary constant will automatically be covered in chapters when we will cover the whole chapter, lectures on structure, whole lecture on pointer, array and union. So let us understand primary constant, integer, real and character. Okay, so then moving to integer constant. So guys, starting with integer constant, now let me give you an example so you will understand better. So guys, okay, so let me so so guys, you can see here, actually I have, this is x and this is x 620 whose value is 6225. So guys, what you should remember for an integer constant, that the integer constant first of all should have at least one digit. So you can see here there are 4 digits. So it should have one digit, and it should not have a decimal, because this is an integer constant. Decimal, you can understand, decimal is represented by dot. So you can't see here dot. So it should, the rules are there for constructing the integer constant. First of all, there should be one digit. You can see here 4 digits are present, so it represents an integer constant. Another rule should be that it should not have the decimal, that is a dot represented by dot. So you can't see here dot. So this also satisfies. So this integer constant can be positive or it can be negative. So here you can see that you are not assigning any sign to the 62225. So default, if you don't assign any signature to that value, then the default it will be considering as positive. So here it is, the sign is, you have not specified, so it will take it as positive. Otherwise you can specify also as -6. You can also specify as -62225, or you can just give 6225. Anything will be working case. Then the next thing is that there is some notation when you give an integer value. That is, guys, you are giving 6225, so you cannot give any space between the 6225. For example, 6 space 225. No, that's not acceptable. Also, you can't give any comma in between these digits, that is 6225, 6 comma 2, 6 comma 2 comma 2 comma, like that you can't give. So these things you should remember. First of all, what all things I told you, let me summarize here. I've already listed these things, so you can refer later. Also, I'm explaining it to you with the diagram, so you'll get a clear picture. This lecture won't be boring because it will be also, I'll give you an examples, and also why I've listed all these stuffs here in this presentation, guys, because I'm saying you now, you will understand, but later if you want to refer it, just going to attending the lecture also, you can attend it, and you can also see the notes which I have written here for your convenient purpose. So you can see what as I explained you, an integer constant must have at least one digit. We have seen here, yes, it is having 4 digits, so at least one digit is enough. Then it must not have a decimal, so you can see it's not having any decimal, right? So it can be either positive, negative. Yes, it can be positive, negative. As we have not specified any signature, it takes as positive. So if no sign precedes an integer constant here, you can see, then it is assumed to be positive. Okay, as in I told you, I am not given any signature, it's taking as positive. Commas or blanks are not allowed with an integer constant. For example, you can see here, example, int x is equal to 6225. So you can see no decimal is present, only one digit is present. All these things, rules which I have specified here, you can see everything is obeyed in this example. So this means it is an integer constant. So guys, one more thing, this integer, it comes in different precision. So what is precision? So guys, precision is like, just a minute. So guys, I just explained you with a notepad for that. So this integer, it will be coming in different precision. Precision in the sense, there is, so first is integer, second is short, another is long. So what is these? What all these are? So see guys, integer, there are different precision, that means different forms. So in integer, it can be 16 or 32 bit size. So all these things depends on the size, guys. So this telling the precision of integer means there are different sizes of this integer form, that is integer, short and long. That means it is these are different 3 precisions that is available in different sizes. So integer will be having 16 or 32 bit depending upon the compiler, on the architecture. It will depend what it can either take a 16 bit or it can take a 32 bit. So depends on the compiler, depends on your machine architecture, like that. The short is always taken a size as 16 bit, long is taken as a size of 32 bits. Short 16 bits and long is 32 bits. So you can see that different sizes are available. So that is the reason it is called as different precision for this integer. So there are 3 precision. So guys, how the notation is, like for short, it can be represented as you can give as, so you can represent it as, like, for example, you are having 620s, or you can have 62s. So always remember these symbols, that is small s and capital S, is given always at the last of the digits. So S or capital S, anything you can give. So if you don't mention also this S or capital S or small s, the compiler will just see the value of whatever you are giving a value to an integer. If it's very small, it will automatically treat it as short. So you also don't need to specify these symbols, S or small s or capital S. If you don't specify, compiler will interpret for you. So just for your understanding purpose, I have just given this notation. Normally we don't mention this S or capital S because compiler interprets it internally. So these are the notations for short. For long, the notation is, guys, 6225, say small l, or you can give 626445 capital L. So small l, capital L, anything will work. Again guys, if you don't specify, not an issue. Depending upon the value, the compiler will interpret for you. Okay guys, so this is the different precisions. Integer comes with integer, short and long. Coming back to the lecture, as in we have seen the rules for constructing integer constant, this one, and I have just mentioned different precisions which can be used as integer, short and long. So this completes with this integer constant. Now we will see the next, that is rules for constructing the real constant. So guys, real constant, now it comes in two forms, that is fractional form and exponential form. So these are the rules for the fractional form. So let me explain here again the example. Let us divide. This is for integer. For real constant, so when I discuss about fractional form, example is say 13.77. Okay, so this one. So guys, fractional form in the sense, so you can see this value, constant value, that is 13.777. So what you can see here, you can see that you are at least one digit is present. Yes, you can see here we are giving decimal. Yes, so this is the difference between the real constant and between integer. In the integer constant, I told you no decimals are allowed, but in the real constant you can give the decimal. So in the fractional form, this is one of the way to represent the real constant. It comes in two forms, fractional and exponential. We are seeing first the fractional, what does it means. So the rules for it is that you should have at least one digit. Yes, it is having. It should have decimal. Yes, it is having decimal. Again guys, we are not mentioning any signature, so the default will be positive. You can either give positive or negative also, anything will be work. So commas and space, all these are rules are specific or applicable for every constant, that commas and space should not be there. So you can see no commas, no space. So this is in the fractional form available. So decimal point, that is fractional form. Okay guys, so coming back to the documentation, the real constant must have at least one digit. Yes, it must have a decimal point. Yes, it can be positive, negative. So all these what I have mentioned here, actually I have explained you this. I have also making a note of it. You can just refer it for reference. So now we have done with the fractional form. Let's see what is the exponential form. So okay, so exponential form guys. So guys, when we can represent any real constant in exponential form, so whenever the real constant is very much, its value is very much small or its value is very much large, then you can represent them in the exponential form. So this is very important point guys. So this can be also asked in an interview. So guys, always remember, whenever they are telling you to differentiate between the fractional exponential, they are asking you, you can just tell the importance of exponential, when you can use it, when its value is very less or value is very large, you can represent them, then the real constant and exponential. So I have also mentioned here for your reference, you can refer it. When the real constant is very small or big, then it can be represented. It's a very important point. That is the reason I marked it, I've highlighted it. So you can just go through it. So there are two parts. So this exponential form is represented in two parts. So that is guys, this is an example of it. See, so guys, 0.00145. So this you can see it's a fractional form, right? So how you can represent it in the exponential form is in this manner. So this is what 1 decimal, that is 0.45 e raised to power minus 4. So guys, you can see here, this is the same value is there, but you are taking a decimal point after 1. So then you can calculate accordingly how much raised to power will be. So 1, 2, 3, 4. If I am taking a decimal after 1, then I need to raise to the power 4. So it's always represented in this format, that is 1.45 e raised to power minus 4. So this is the exponential form, guys. And this is, you can see, this is a fractional form. So you can see the difference between both of them. So if the value is very small and very large, then you can represent it in this manner instead of representing it in a fractional form. So guys, there are rules for the exponential form. So the rules are almost similar for the real constant in fractional and in exponential. That is, first of all, guys, this thing you have seen 1.45 e raised to power minus 4. So guys, here you can see the part which is appearing before this letter E. So you can also give small letter E or capital letter E, anything will be workable. So the part which is before this E is called, that is this one, 1.45. So 1.45 is called as mantissa, and after E, the part that is power raised to minus 4. So E raised to minus 4, so this minus 4, this part is called as actually as exponent. So there are two parts in this fractional form. This whole is represented, in the exponential form, this whole is represented exponential form. This is a fractional form, and this is an exponential form. So the part which is in exponential form, the part which is appearing before E, all this 1.45, is called as mantissa, and that the part appearing after E is called as exponential form. Okay guys, so all these I have written here actually, and always remember the rules are, that is E. So you should always separate the mantissa as well as this exponent part by this small E or capital E. This is one of the rule in case of representing it as an exponential form. Another rule is that, guys, this 1.45 can be positive or it can be negative. Okay, if you don't mention here, you are not mentioning any sign, that means it is positive. For actually, in case of the part that is after E, which is called as exponent actually, it can be also positive, can negative. It should have at least one digit. So here you can see 4 is present. If you don't mention any sign, it will be positive. It can be positive, negative. All these things which are present. So guys, you just refer this notes actually, which also you can understand clear cut what I, by the example, all it's by clear cut what it says. So I have given you examples so that you can sing whatever notes we have written here. Simple thing, this is the fractional form and this is an exponential form. Fractional form, you can see one decimal is present. So here also this decimal is very much important. So this should be present actually here. So the part appearing before E is called as mantissa, part appearing after E is called as exponent, and these are the rules again. It can be positive, negative, and all these things which I mentioned here should have at least one digit. So guys, just refer to it. So guys, the real constant in exponential form, they have the range of like this, minus, you just see the range, minus 3.4 e raised to power 38, 3 to 3.4 to the power e raised to 38. Okay guys, so we are done with this second part, that is we are done with the real constant. So now coming with character constant, guys. What is character constant? So character constant is, first of all, it is any character which is represented with a single quote. That is, guys, so character constant is like here, it can be this, it can be this, it can be this. Okay guys, so character constant is any character which is represented within the single quote. So single quote is this is the symbol for the single quote. You can see here, single quote open, single quote close. So here you are mentioning any character which is there in a single quote. Always remember, character constant will be always represented within the single quote, and it should have only one character. So you can see character can be a alphabet, let us say it can be a number that is 1, or it can be any specific symbol, guys. So anything can be present actually, so that should be within a single quote, so that represents a character constant. So I've also mentioned here the definition. So two things can be performed with this character constant. Either you can do any numeric operation with this. So suppose if you do this addition operation with this character constant, you add this character constant with one more, say with you add in this manner A and B, then you can also do addition because its ASCII value will be calculated and its operation will be its ASCII in the ASCII form. So numeric operation can be done on it, and for the comparison also, so you can also compare whether this character is equal to B. So two operations can be performed with this character constant, guys. So guys, and this slash character in this slash n is also a character constant. You can see slash is also there, n is there. There are two characters, and why I'm saying, but this represent as single only in this term. So this is also treated as a character constant. So there is things which are defined which should come in a character constant. So guys, this slash n is called as a escape sequence. It means it's a new line. So guys, these are the list of the escape sequence. You can just refer actually. So slash a is alarm or beep, slash b is backspace, slash f. So guys, you might be aware of the slash n because I've used in my earlier program in the previous session. For your reference, I have given a free video of 1 hour as well as of 10 minutes which explains the basic stuffs. You can just refer to the previous session where I explain you different small programs so that you can get in touch with C. You'll be very much confident actually. So just this we have already used. This is used in order to print a line in a new line. So the slash n means new line. So for readability purpose is very much required. So these are different escape sequences. You can just refer this, guys. For your reference purpose, I have just made a note for it. You can refer all these things. So now we are done with this character constant, guys. Coming with another constant, that is string constant. So guys, what is string constant? So string constant is always, remember, it's always represented by double quotes. So you can see any array of characters which are represented by within a double quotes is called a string constant. So guys, this is also string constant. Even I'm writing one character only, but I'm specifying it within double quotes. That means it's a string constant. So character constant is represented by single quote. String constant is represented by double quote. Always remember, guys, even if I'm writing this GSSSGS, but internally the compiler will treat this in this manner. GS this. Okay, guys. So I'll explain you all these things detail in the chapter string, but still, since I have started this using this terminology for your reference, let me explain in short. Like slash 0 means a null character. So whenever you're writing any string, always compiler will take this slash 0 at the end of this string. So it will take internally slash 0 also. So we will see in detail in our next chapter. When I'll cover the chapter string, I'll cover each and every point, so you'll understand in detail what does it mean. Just for now, understand string is always represented within the double quotes, and even if you are giving single character also, it will be treated as string if you are mentioning it in double quotes. So internally compiler will also take this character as and this slash 0 also. Okay, guys, so moving to the definition here, I've written double quotes is called as a string constant. So guys, this is one more important point in this character and string. So guys, this is also very much important for interview point of view. What is difference between character and string? So you have seen that character is represented by single quote, string is represented by double quote. That is one of the difference. Important difference is that, guys, character constant always, you remember, since I have told you this, in case of character constant, this ASCII value, you can do numeric evaluation, and because their ASCII values will be evaluated, and you will get the answers in ASCII value, and then so therefore you can be using character constant numeric evaluation. So character constant, these are the integer only represented as a numeric value of correct in machine character set. The same thing, that numeric evaluation can be done with this character constant, is an integer only. And whereas in case of string, you have seen the string is an array of characters. So character you can constant, you can do numeric evaluation because ASCII value will be calculated. But in case of string, it is an array of characters, so nothing that can be possible. So this is the difference. This is very much important for interview point of view. Coming back to the enumeration constant, that is last one. What does the enumeration constant is? It is a list of constant integer values. So I have given many examples for your convenient purpose. Everything I have covered here. So let's see in detail. So guys, here only I have explained it. So example, enum, boolean, no and yes. So guys, you can see this, we are representing no, yes. So these are written in the capital letter. So guys, it's similar to that of symbolic constant actually. That is when you do hash define, that is hash define I've discussed detail in preprocessor session, which I have covered in the basic concepts, wherein I've specified hash define capital letters, we give the name actually as, and then some value. So this is similar representation, just why I'm telling, because it's a similar representation. You can see here we are giving capital no. So what does it mean? So here guys, we are giving no comma yes. So internally these values will be, no will be automatically will be 0 and yes will be 1. So it is auto generated. So even if you are giving any variable here in capital letter, the compiler will treat this first variable as 0, next variable as 1. Since you are not specifying any value, it will auto generate for you. So that is the difference between this and between hash define. Hash, even if you are using the name in capital to represent any value, but here in similarly to that of the hash define, you are giving name and then some value. But difference between hash define and between this is, here the values will be auto generated. There you need to give the value, but this, if you don't specify, it will be auto generated in the sense, if you just give no and yes, the compiler will treat this first variable as 0 and another variable as 1. So I've written this in the note. So important point in this is also very important for interview point of view, it's an auto generated. Okay guys, so first example is this. Second example is, guys, we can give also in this form, that is new line is equal to slash n, vertical tab in slash v. You can give in this format. So here even you are specifying some value actually, there is new line, so it will start with this value only, that is slash, and if you don't give any value, then it will treat as 0. If you give a value, it will treat this value. So here it will be new line, here you are giving slash v, that means a vertical tab. So all these things. Then the next one is example 3 is this one. So guys, you can see here I'm doing Jan is equal to 1, Feb, March. I'm not giving Feb is equal to 2 or Feb is equal to 3, anything I'm not giving. So this is also, this is workable in this case, because what the compiler will do, it will see, yes, you have specified Jan is equal to 1, you have not specified Feb. So it will see the last specified value, yes, it is 1, and it will start in the continuation with that, progressing this 1 to 2. So this will be 2, then March will be 3. So here I have specified, this is an important note, even if you don't specify some of the values, some values you specify, some you don't specify, so it will start from the continuation of the last specified value in progression of it. That means 1 is, this is 1, so its Feb will be 2, March will be 3. So this covers actually, guys, example of numeric constant. So guys, you can see I have explained you with the diagram, with the details here actually, and this is the points which I have made a note of here. Also I have covered important interview related questions, so just please refer this, it's very much important topic. This is, we will be using everywhere in our program. So I'm done with this constant lecture. Next you can start with the integer lecture, so that I will cover a different lecture for it. So guys, I'm done for now. Thanks a lot guys. Thank you.